Welcome to 4A Notes. So we're graphing quadratic functions in standard form. So first, we're going to find the vertex using A, B, and C. Actually, it's just A and B, because here's our equation. X equals the opposite of B, or negative B over 2A. So in our equation, we have, let me zoom this in, we have our A is 1, our B is a positive 2, and our C, which we actually don't need for this formula, is 3. So in the formula, we have X equals opposite of B over 2 times A. And this is going to be our X value of the vertex. Vertexes are X and then Y. So our X is going to be negative 2 on the numerator over 2, which is negative 1. That's our X value of the vertex. So the vertex is, what did I just say? Negative 1, and the Y value. So now what we need to do is we need to take that negative 1 and we need to substitute it back into the formula, the original standard function. So f of negative 1, so we're substituting negative 1 in for x. So negative 1 squared plus 2 times negative 1 plus 3. Negative 1 squared is positive 1. 2 times negative 1 is negative 2 plus 3. Negative 1 or 1 minus 2 is negative 1 plus 3 is 2. So our vertex is at negative 1, 2. Now, we're going to find two values to the left or to the right of the vertex. So this is where we had our x values. So we had our x values. Let's make this a box. And then we're going to have our f of x, which is our y values. Oh my gosh, that box was awful. Let me erase that quick. That was the worst box in history. And we need to have 5 different lines. Oh, this is going to be awful too. Oh my gosh, that is so terrible. Anyways, our vertex is at negative 1, 2. So I'm going to put that right in the middle. Negative 1, 2. This is the vertex. Quadratics are always like U-shaped or they're upside down U's, but they are symmetrical about the vertex. So the vertex left and right are the same. So if I go the same distance left of the vertex and the same distance right, our y values are always going to be the same. The y's are going to be the same. So if I go the same distance left as I go right, the y values are going to be the same. So from negative 1, I am going to go by ones on a number line. So I'm going to go with negative 2, negative 3, and then 0 and 1. Because of quadratics being symmetrical, I only need to substitute in either 0 or 1 or negative 2, negative 3. So I'm going to put in 0 because I like that number better. So f of 0 equals 0 squared plus 2 times 0 plus 3. And we have, that's going to end up being 3. So if 0, x value of 0 is 3, then negative 2, since that's the same distance from negative 1 on a number line, negative 2 is also going to be 3. And let's substitute 1 in. 1 squared plus 2 times 1 plus 3. So 1 squared is 1 plus 2 plus 3, so that's 6. And since 1 is 2 away from negative 1, negative 3 is 2 away from negative 1, so that's also 6. So let's plot this point. So we have negative 1, 2, negative 1, 2. We have 0, 3. We have 1, 6. It does not matter the order you plug these in. We have negative 2, 3. And negative 3, 6. And then we draw a nice quadratic. And that is it. So let's do, I'm going to do number 5. Yeah, let's do number 5. So we get the vertex, so we have our A, our B, so we have x equals the opposite of B plus over 2 times A. That's going to be negative 2 over 1, which is negative 2. Let me erase that. I don't like the negative 2 there. So our vertex is at negative 2. on the x, so then we substitute in negative 2 1/2 times -2 squared plus 2 times -2. That's -2 squared is +4. 2 times -2 is -4. Half of 4 is 2. And -2 is your y value. So we're looking at numbers from -2. If your a is negative or has a denominator, what I would do is I'd go by 2's. So instead of going by 1's from -2, the x value of -2, so I'm looking here, I'm going to go by 2's. So I'm going to go -4 and -6. I'm going to go 0 and 2. The reason why is because we're going to be dealing with a fraction. If you always go by the denominator, when we substitute these numbers in, the fraction will go away. And we'll be left with nice integers versus fractions. You can go by 1's, but you're going to get fraction-wide values, and that's fine. I just don't want to deal with it. So I'm going to put in 0, and you'll see that we're not going to have any. So 0 is going to end up with 0, and 2, when we substitute 2 in, you'll see that it actually, so this is 4, 2 squared is 4, half of 4 is 2, 2 times 2 is 4, 2 plus 4 is 6. So I'm not left with a fraction, no decimal, it's great. So we have 0 and 6. So -2, -2, 0, 0, 2, 6, -6, 6, and -4, 0. And here's my quadratic. All right, next problems. I'm going to multiply these together. X times x is x squared. X times -5 is -5x. -3 times x is -3x. And -3 times -5 is a +15. Get your like terms together. The middle two are like terms. And now we have our standard form. This is where you'd find the opposite of -b, or opposite of b over 2 times a. So it's going to be 8 over 2, which is 4. And so our x value is 4. Let's substitute it in. 4 squared minus 8 times 4 plus 15. That's going to be 16 minus 32 plus 15. That's going to be -1. We don't have a denominator, so I'm going to go by 1. So 5, 6, 3, 2. I'm going to substitute in 2 and 3. Those are smaller numbers. So when I substitute in 2, so that's going to be 4 minus 16 plus 15. That's going to be 3. And when I substitute in 3, (9 minus 24 plus 15), that's going to be 9, wait a second, -9, 9, 0. So 0 and 3. So -4, 1, -1, 5, 0, wait, 5, 0, wait, 9, I just got that wrong. So 4, 0, 4, -1, get it right, 5, 0, 3, 0, 6, 3, and 2, 3. There's my nice quadratic. I hope this helped you. Come to class with any questions.